Okay, what we're going to do in this video is try to give you an introduction into using Hypermesh. So as we're going to start doing two-dimensional problems and three-dimensional problems, it's going to be a little tedious trying to hand input all the element and connectivities and the node coordinates. So a preprocessor like Altair Hypermesh is really an excellent thing to try and use. And I like Hypermesh. I think it actually is the best one out there. It does a real good job of handling different finite element solvers. So if you learn, you only have to learn one interface basically, and also the meshing capabilities are really good, so you can quickly make very high quality meshes. So for those two reasons, I think it's one of the best ones. We're fortunate enough to have it here at UTEP. Okay, so this will be the problem we're going to solve. It's going to be a plate with a hole in it under remote tension. So we're going to use two-dimensional elements in Nastran. We're going to set the problem up to run in Nastran. All right, here are the dimensions. So basically, the stress in the far field region should be about 10 ksi. The stress out towards the edge by the hole, because the area reduction should be about 13 ksi. And then, considering the fact that you have a stress concentration because of the hole, here's the stress concentration factor. It gives us a peak stress right at the hole here, edge, of 31 ksi. Okay? All right, and then actually to do this, we are going to model this with quarter symmetry. So I'm just going to model 1/4 of the plate, just this region here, and we'll put basically symmetry boundary conditions on the edges, which are basically allowing rollers, okay? So those define the two axes of symmetry, all right? Okay. Now before we dive into the Nastran stuff, let's at least talk about the approach. So this is not the only way to set up models in Hypermesh, but I think this is a good approach to start. You don't have to use this particular order, but I think if you do this, it'll make life a little easier, at least to start. You can always actually just start making geometry and then move things around, but if we do it in this approach, we can kind of go through without having to reorganize the model too much. So this is kind of cascading down in the order in which things are referenced, all right? So the first thing we're going to do is define the material cards, the Mat1 cards. And then we're going to define the property cards, the element property cards. In this case, it's going to be a P shell, because the P shell calls the mat card. And then we're going to define a component collector. Now, a collector is an Altair term. That's not a Nastran term. And that's basically like a layer or something, or a bin that holds a bunch of stuff. In this case, this collector is going to hold all the elements and nodes that define the mesh for this quarter symmetry plate. Okay? That'll be the first step. Then we'll actually construct the geometry and make the mesh. Okay, that's the next two groupings of step. Once we have the mesh of the geometry, we then have to do boundary conditions. So actually, boundary conditions are going to go on collectors themselves. They're called load collectors. That's again a term used by Hypermesh. So we're going to define one load collector to hold the SPCs and another load collector to hold the forces or the tractions. Okay, so we're going to create the load collectors, and then we're actually going to create the SPCs. Then we're going to create the load collector for the force, and then actually collect the forces. Okay, so now we have the mesh and then the boundary conditions. The last thing we have to do is define the load cases and then export the file, the Nastran file, until we can solve it in Nastran. All right. So we'll define the load cases and then we'll export the Nastran file. Actually, before we solve it in Nastran, I will open up the Nastran file and then edit it a little bit to put a couple things in that weren't put in with our Hypermesh model. In fact, You can define fully the Nastran model inside of Hypermesh, but I'm just going to do that just to show you how it works, okay? All right. So let's start by loading up Hypermesh. So this is the my desktop thing. So if we go under all programs, there's Altair HyperWorks. There's lots of programs that make up HyperWorks. The one we're going to use to start with is Hypermesh. So if you click on that, it'll pop up. And now this is the type of window you'll get. All right, the first thing that pops up is this user profile window. This is pretty important. So this is what's going to say, am I making a finite element model to run in Nastran, LS-DYNA, ANSYS, Abacus, so on and so forth, okay? So it changes the interface slightly and the options slightly depending on what solver you're going to use, okay? So we're going to use Nastran, all right? So you click on Nastran if it's not the one that's clicked, okay? And then you hit OK. All right, so up here, where is it? You can see that we're in the Nastran mode. That's the user preference. If I go back here to preference, I can see user profiles. That brings up that window again. So you can change it later on. If you got to go to import a file from Nastran to make it LS-DYNA, you can do that. All right. So if you do it later, that's under preferences, user profiles. Okay. All right. This is the graphical window. This is where you see stuff. Actually, this is kind of the older menu selection. I actually like this, but everything that's down here, you can see it has sort of sub-menus. This, if I click on the radio button here for geometry, here functions that allow me to define geometry. 1D, if I click on that radio button, it gives me functions to define one-dimensional meshes. Likewise, 2D gives me functions to define two-dimensional meshes. 3D is for 3D meshes. If I click the analysis radio button, this gives me options, or I should say functions, that let me define load steps, forces, constraints, which are SPCs and other types of control cards. Then you have another one that's tools. This lets you do things like edit, delete, move things around. And then once you have a solution, you can actually do some post-processing in here. Okay, actually look at the results, okay? Now all this stuff is also up here. And this is kind of in your more classic pull-down menu. So for example, geometry radio button. You can see if I go up here to geometry, it has, create all the items that are down here for the most part. They're a little different order. So it depends on what you like. I will probably use these more. Well, I'll try to use the pull down menus because I think most people are probably more used to that, although I'm more comfortable with this. Okay, these tabs here are kind of nice. The most important one to look at now is make sure we're clicked on the model tab. So this is going to show me the organization of my finite element model. As I add materials and property cards and element collectors and load cases, it'll all show up here and you can organize them. This bar down here allows you to change the way things are represented. And then, well, it's a little tough to see, but if you want to navigate in the graphical window, if you hit Control and the left mouse button, you can rotate. Control and the middle mouse button allows you to draw little zoom windows. It's a little tough to see how that works now. And then Control and the right mouse button allows you to pan. Again, you can't see it on everything up here, but we'll do that later on. Okay, so it's going to be Control and the mouse buttons. The various mouse buttons are what let you dynamically rotate, pan, and zoom. Okay. All right. Well, let's get started. So let's do our first step, which was to actually define the materials, the properties, and then define the component collectors. Okay, and at that point, I'll probably stop the video and then start up with the second video to do this second major step and then the SPCs and so on and so forth. Okay? All right. So to make a material, you can either right-click under Model, and it has various creates, material, load collector, components, so on and so forth. Or you can go up to here to material and do create. Alright, so you'll get a menu like this. Since we're in the Nastran mode, user profile, you can actually pick from the various Nastran material cards. Now we've only used Mat 1, so we'll define a Mat 1 card. So you can see it knows the different the different Nastran materials. If you had it set to Abacus, you wouldn't see Mat 1. You would see whatever selections are available for Abacus. Here you can give the material a name. Let's just call it, we'll make it out of aluminum. And then if you do create, now all, don't worry about all so much. It just allows you to sub-select different types of materials. So if you pick an isotropic, you can see Mat 1 goes away because Mat 1 is an isotropic material. If I pick all, Mat 1's available again. Okay? Oops, Mat 1's available again. There it is. All right, so let's create. Now when we hit create, oh, it didn't bring up the edit. Okay, so we need to edit it. When we hit create, you can see, in fact, we got two things here. We got a little thing that says materials, and under materials we have one material. So if we have multiple materials, they would all show up here. But here's the aluminum material. It also gave me a little title card. Now all these things that show up in the model, you can pretty much right click on them to edit. So I can like right click on the aluminum and edit it. Okay. Now we actually have to go in and put in the properties. So there's edit, but when we want to actually edit the card inputs like you would in Nastran, you know, these are the different fields, you want to use the card edit. So when I right click on aluminum and hit card edit, you can see what pops up is a little spreadsheet that looks just like the input in the Nastran reference manual. Okay, these are the fields that you would actually type in your DAT or BDF file. All right, here's the ID that you can't edit; it automatically assigns that. Young's modulus, Poisson's ratio, density, so on and so forth. So let's make the material. Let's give it. We'll use inches here, pounds. So we'll define Young's modulus as 10 to the 6th psi, and we'll put in 0.33 for Poisson's ratio. It's really all I need to do. You can actually see here you can add additional lines for other optional lines in the Mat 1 card. But that's all we need. So you just hit it and you hit return. And now it's created. Okay. So for example, you can go back later on and edit those if you want to. Okay. All right. Likewise, I can go into title and I probably can card edit that and type in a title. I thought, well, maybe not. It doesn't let me do that anymore. It used to let you do that. Oh, there's no, it says here, no card assigned, so, but that's all right. All right, so we've created the material. All right. Let's go back and see where we are here. So we've created the Mat 1 card. Now we're going to make this model here out of shell elements. Really, Nastran doesn't have separate two-dimensional elements. Everything is viewed as a shell element. The in-plane behavior of a shell element really mimics a plane stress element. So basically we're doing plane stress here. All right. So again, to create those, you can either right-click here and hit create, and you can see that there's a property card. So those are all the various P cards. Or again, up here, you can do it. So we can create a property card. And we're going to give it a name. We're going to call it plate. Plate property. Now, the card image is the one that actually, selects the various P card out of Nastran that you can use. So here you can see we got the P bar L, P rod is down here somewhere. P rod. What other ones have we used? P beam. There's the P beams. Okay, but we're going to use a P shell, so we're going to call it P shell. and then hit create. All right. And now you see we've got property and we have the plate property in here. So again, I can right click on this and do card edit. And now again, I've got the P shell card that you would get in Nastran. It has a property, no material assigned. I have to pick the material. And then it has a thickness. So we're going to give it a thickness of 1. And then we're going to hit return. Okay. Let me just see one thing. If I create a new one, does it allow me to assign a material? Let me do this again. Here, now there's no material assigned to this, so we could go back and assign a material under, if you go card edit, you can see here's the material field. I can't really edit that. Altair wants to kind of control that stuff for you, so it doesn't allow you to screw it up. So we need to assign the material to that. So I believe if I right click, I can assign. Nope, that's assigning it to elements. Maybe I can assign this material. Nope. I think I have to go back up to here and do materials, no, do properties. Organize. Yeah. I'll tell you what we're going to do. We're going to go back and go back under plate property and hit edit. And here you can see there's a material tab. I can actually assign the material to it. And I'm going to pick the aluminum one. That's the aluminum one we created, you see? So now we update it. And now if I go back to plate property and do the card edit, whoops. You can see it has the materials set to it, material ID 1. That's the material we had. That's the material ID for that guy. Okay, likewise, you know, when you do create, you could have created a property and you could have assigned the material initially right through there, okay? But there we go. So now we've got the plate property, the P shell card. It's fully defined, it's got the thickness defined, and then it has the material assigned to it, okay? You can see if we hit mid 1, we can add different option fields. You can do a continuation card and put in the next line. That's optional, but we won't do those, so we'll just leave it at the basic one-line P-shell definition. We won't use the other optional lines, okay? All right. So now we have the material and the property. So now we can start making geometry, but we need to create the collector, the bin that's going to hold those. So that's a component. So again, component is a Altair concept. It's not an Nastran concept. So here's the component. This is going to hold, it's like a layer. It's going to hold all the elements that make up the mesh for the plate. So let's give it a name. We'll call it plate. Okay, we can change the color. That's going to be the color of the elements. We can make it like more cyan. We can assign a property. So we're going to assign the plate property card, the one we just created here. And then we can also assign a material, but that's carried over from the property card, okay? And then if we hit create, we've got a component. It's called plate. And now if we start to create geometry, it'll show up in this plate component, okay? If we had multiple components, I won't in this one, but we'll have, you could create another component and you can see, you know, you can give it a different color and you can change whether or not they're current or not. This is kind of an important concept. Again, we're just going to have one component, so it's not a big deal here, but see if you right click on the node in the model sidebar, you can toggle and make things current. So when you make it current, it becomes bold. That means that when I create geometry or create elements, it's going to go into this component. So We don't really need this, so we can delete it. Okay. Yes. All right. Well, why don't we start to make the geometry, and then we'll stop the video. Well, actually, no. I'll stop now because I think I've gone over kind of the 15-minute limit. Okay. So let's stop it here. The next video, I will create the geometry and make the mesh. Okay.